Hello everyone, I am Balaji Rao. Welcome to BR Max class. Let me check. Yes. Uh, Good morning to all. And in this class, what problem we are going to discuss? You observe this question number 14. Discuss the continuity of the function f, and this function is like this. Till now, whatever the problems we did in continuity, this problem, little difference is there. That is in the domain of the function. Okay, so in this class, we are going to discuss only this problem, question number 14. Before going to start this video, please drop a like for this video and share this video with your friends. So let's start the class. Okay, you observe this question number 14. What they are asking? Discuss the continuity of the function f. We need to discuss continuity of this function, and the function is defined like this. This is the given function. To discuss continuity of this function, I need to know domain of this function. What is domain of this function? Is this function defined for all real numbers? For example, x equal to -1. Then which function to choose? -1. When x equal to -1, which function to choose? You can observe this first one. This is in between 0 and 1 only. In this interval, -1 is not there. And you observe all these things are greater than 0. So, when x equal to -1, which function to choose? This function is not defined when x value is -1. Okay. So, this function is not defined when x value is -1. Suppose x equal to 100. Then which function to choose? X equal to 100. You can look here. This interval is from 3 to 10 only. When x value is 100, this function is not defined. So what is the domain of the function? You can clearly observe that this function is defined when x value is in between 0 and 1, including 0, and in between 1 and 3, in between 3 and 10. So here the point is the domain of this function is closed interval 0, 10. Is this clear? The domain of this function is closed interval 0, 10. Yes, correct. The domain of this function is closed interval 0, 10. Discussing the continuity is meaningful when we discuss the continuity on its domain. So I need to discuss continuity of this function in this interval only. Okay, so I'll mark this closed interval 0 to 10 on the number line. Okay, so here you observe. Now I need to mark few things here. First thing, 1 minute. Right, this is 0. Okay, this is 0 and this is 10. So I considered closed interval 0, 10. See, 0 is included, 10 is also included. Now what is where the function is varying? You observe where the function is varying. At x equal to 1, the function is varying. At x equal to 3, the function is varying. Right? So I'll mark this 1, 3 also on the number line. Okay, I'll mark this 1 and 3 also on the number line. I'll mark these things also on the number line. Now, in how many cases we are going to check the continuity of this function? That is important. Here, what is the difference between this problem and earlier problems? Earlier problems, domain is all real numbers. For this problem, domain is on closed interval 0, 10. When domain is closed interval 0, 10, checking the continuity is little tricky part. We do this problem in 7 cases. What is case 1? I'll check the continuity of the function at x equal to 0. Here, to check the continuity of the function at x equal to 0, when x value less than 0, the function is not defined. So I'll check right continuity of the function at x equal to 0. What is case 1? I'll check right continuity of the function at x equal to 0. That is case 1. So I'll mark that. Right continuity I'll check. I'll take it as case 1. What is case 2? When x value lies in between 0 and 1, then I'll check the continuity. So when x value is in between 0 and 1, then I'll check the continuity. That is case 2. That is case 2. Okay. What is case 3? I'll check the continuity of the function at x equal to 1. Okay. That is case 3. I'll check the continuity of the function at x equal to 1. That is case 3. What is case 4? I'll check the continuity of the function when x value is in between 1 and 3. Okay. That is case 4. I'll check the continuity of the function when x value is in between 1 and 3. What is case 5? I'll check the continuity of the function at x equal to 3. Okay. So this is case 5. Okay. What is case 6? I'll check the continuity of the function when x value is in between 3 and 10. Okay. When x value is in between 3 and 10, I'll check the continuity. Okay. This is a case 6. What about last case? You observe at 10. What to check? When x value is greater than 10, the function is not defined. So I'll check left continuity of this function at x equal to 10. I'll take it as case 7. So I am going to do this problem in 7 cases. Okay, case 1. What is case 1? What is case 1? Checking the right continuity of the function at x equal to 0. Okay. When we say the function is right continuous at x equal to 0, limit x approaches to 0 from right, f of x equal to f of 0. When this holds good, then I say that the function is right continuous at x equal to 0. Okay. So I am going to do that. Solution for this problem, that is case 1. What is case 1? I am checking the continuity of the function at x equal to a, and what is a? I am checking the continuity of the function, right continuity of the function, so I'll write 0 plus here. What this 0 plus indicates? All x values are greater than 0. I am just checking the right continuity of the function at 0. I cannot check left continuity of the function at 0 because this function is not defined when x value is less than 0. Okay, so right. So the point is I am going to check this one. To check this one, first I'll calculate limit x tends to 0 from right f of x, and I'll calculate f of 0. If both values are same, then I can say that this function is right continuous at 0. Okay, so first let me calculate this one. Okay, limit x approaches to 0 from right f of x. Okay, that equal to limit x approaches to 0 from right. X approaches to 0 from right means all x values are greater than 0. We know that. X approaches to 0 from right means all x values are greater than 0. When x values are greater than 0, which function to choose? You observe here 0 less than x. 0 less than x means x is greater than 0 only now. So which function to choose? We need to choose this 3. Okay. So the function is 3. Now I need to calculate this. How we will calculate this? Direct method. What is direct method? In the given function, wherever x is there we will write 0. But in the given function x is not there. So directly its answer we can write it as 3. So I calculated this. I got its value as 3. Now I will calculate f of 0. Okay. Calculate f of 0. Okay. Calculate f of 0. To calculate f of 0, you need to know what is the function to choose. Here, x value is what? You observe f of 0, f of x, f of 0. X value is 0. When x is 0, look here, equality symbol is there. When x is 0, which function to choose? I need to choose this 3. So, f of 0 is what? When f of x is 3. What I am trying to say? F of x is 3. What I am calculating? I am calculating f of 0. In place of x, here 0 is there. So f of 0 in this function, wherever x is there we will write 0. Actually this is constant. So what is f of 0? F of 0 is 3. Not only f of 0, f of 100 also 3 only for this function. Okay, we all know all those things from functions chapter. F of 0 is 3. So what happened? I calculated this, I got 3. I calculated this, I got 3. So what I can say? limit extends to 0 from right, f of x equal to f of 0. This is true. So I'll write this one. Limit x approaches to 0 from right. Therefore, limit x approaches to 0 from right, f of x equal to f of 0. These two are equal because both are, we got it as 3. So what I can say? I can say that f of x is, therefore, f of x is right continuous at x equal to 0. Listen here, f of x is right continuous at x equal to 0. So, case 1, what they are asking in the question, discuss the continuity of the function. I checked at right continuity, this is the right continuous at x equal to 0. Now, I need to check the continuity of the function when x value is in between 0 and 1. Okay, case 2. What are the things needed? I'll carry forward those things. This function we need. Okay, and I need this number line also. We'll carry this one along with us. Okay, right. So case 1 is over. What you got at case 1? At case 1 it is continuous. Okay. Case 2. What is case 2? In this interval I am going to check the continuity. Okay. Case 2. Case 2. At x equal to a. What is a value? 0 less than a less than 1. Okay. I need to check the continuity at x equal to a value is in this interval. When I say f of x is continuous at x equal to a, hero of the story. When I say the function is continuous at x equal to a, limit extends to a, f of x equal to f of a. Then I say that the function is continuous at x equal to a. So what I'll do, I need to calculate this one and then I'll calculate this one. If both are equal or not, I'll check. If both are equal, I can say that function is continuous at x equal to a. Okay, limit x approaches to a, f of x. I need to calculate this. Okay, limit x approaches to a. Here x approaches to a value is in between 0 and 1. Then which function to choose? Ashu Jangara, thank you. Then which function to choose? I need to choose this one, 3. I need to choose this function. So what I'll do, in place of f of x, we'll write 3. In place of f of x, we'll write 3. Okay. So now what to do? I need to calculate this limit. How to calculate? In the given function, wherever x is there you write a. But in the function x is not there. So what you will get here? This equal to 3. So when I calculate this value, I got its answer is 3. Now I need to calculate f of a. Okay. To calculate f of a, first we need to decide which function to choose here. You are trying to calculate f of a. A value is in this case in between 0 and 1. When a value is in between 0 and 1, we need to choose this function. So here f of x is 3. As f of x is 3, what is f of a? F of x is 3. This is constant function. Whatever x value you take, f of x is 3 only. What is f of 100? F of 100 is 3. What is f of 1000? F of 1000 is 3. What is f of a? F of a is 3. So here f of a is 3. What happened? I calculated this. I got 3. Now I calculated this. I got 3. As these two are equal, I can say that these two are equal. So what I can conclude? I can say that limit extends to a, f of x equal to f of a. Therefore, limit extends to a, f of x equal to f of a. When you got this, what you can say? You can say that this function is continuous at x equal to a. So I'll write that. Therefore, f of x is continuous. F of x is continuous at x equal to a. What about a here? A value lies in between 0 and 1. So I am checking the continuity in this zone. What I got? I got that it is continuous whenever a value is in between 0 and 1. So they are asking to check the points of discontinuity. Then in this zone I got that. In this zone I got that it is continuous. It is right continuous. In this zone also it is continuous. Now I am going to check the continuity at 1. At 1. So this is important because we are going to calculate left hand limit, right hand limit to calculate this. Let's see how to solve this. Okay. Case number 3. So what are the things needed? We'll take with us. Okay. Case number 3. Case 3. I am going to do this problem in 7 cases. At x equal to a, what is a value here? A value is 1. A value is 1. I need to check the continuity at x equal to 1. When we say function is continuous at x equal to 1, hero of the story, limit x approaches to 1, f of x equal to f of 1. Limit x approaches to 1, f of x equal to f of 1, then we say that this function is continuous at x equal to 1. Okay, so for that what I'll do, I need to calculate this one. We have a problem to calculate this. What is the problem you will get? Let's see here. Limit x approaches to 1, f of x. I want to calculate this. Okay, limit x approaches to 1. X approaches to 1. What it means? It means that all x values are slightly less than 1 or slightly greater than 1 but not 1. This is what we are learning from the beginning of this continuity. X approaches to 1 means all x values are slightly less than 1 or slightly greater than 1. X value less than 1 means in that case we need to choose this function. When x value greater than 1, look here, 1 less than x means x greater than 1 only. When x value greater than 1, we need to choose this function. Here, what I am trying to say, x approaches to 1 means which function to choose. Actually, both the functions are eligible. We can write 3 here, we can write 4 also. But at the same time, you cannot write 3 and 4. So, to avoid this confusion, you need to calculate left hand limit, right hand limit. Look here, left hand limit. Listen carefully. What I am trying to say, I need to calculate this value. When I try to calculate, I got a confusion that which function to choose. To avoid that confusion, I need to calculate left hand limit, right hand limit. Okay. I am calculating left hand limit at x equal to 1. Limit x approaches to 1 from left, f of x. X approaches to 1 from left. X approaches to 1 from left means all x values are less than 1. This we discussed in first class only. X approaches to 1 from left means all x values are less than 1. When x values are less than 1, which function to choose? This first function. So what you will get here, f of x is 3. Limit x approaches to 1 from left, f of x is 3. So I need to calculate this one. How you will calculate this? Direct method. In the given function, wherever x is there, there will write 1. But in the given function, x is not there. So directly you will get answer as 3. So I calculated left hand limit. I got its answer as 3. Now I will calculate its right hand limit. X approaches to 1 from right, f of x. Okay, that equal to limit x approaches to 1 from right. X approaches to 1 from right means all x values are greater than 1. X approaches to 1 from right means all x values are greater than 1. When x values are greater than 1, which function to choose? I need to choose this function 4. So here f of x is 4. Now I need to calculate this. How to calculate? By direct method. What is the direct method? In the given function, wherever x is there, there will write 1. But in the given function here, x is not there. So its answer directly we can write it as 4. All these things we learn in limits chapter. So when I calculated left hand limit, I got 3. When I calculated right hand limit, I got 4. Look here, left hand limit is not equal to right hand limit. What you can say? Left hand limit is not equal to right hand limit. When left hand limit is not equal to right hand limit, what we say? Limit of this function exists or does not exist. When left hand limit is same as right hand limit, then only we say limit exists. Otherwise we say limit does not exist. Correct? So what I'll write here, therefore limit x approaches to 1, f of x. What is this value? This value does not exist. Why? Because left hand limit is not equal to right hand limit. Actually what I am trying to check this condition. In the process of checking this condition, first I am trying to calculate this. What I got? I got that this value does not exist. When this value does not exist, how I can check these two are equal or not? I cannot check. So that's why I'll say that this function is discontinuous at x equal to 1. So I'll say that therefore f of x is discontinuous. F of x is discontinuous at x equal to 1. So I am checking the continuity on its domain. In that procedure, at case 3, what you identified at case 3, this is discontinuous. So I'll mark it. It is discontinuous. In what way? Right, I'll take this one. Look here, this one. At 1, look here, at 1 into mark, that means at 1 it is discontinuous. Okay, now what is case 4? Case 4, I need to check the continuity when x value is in between 1 and 3. Okay, case 4. Before starting case 4, what things are needed? We'll carry forward. The function is needed and this number line we need. Okay, right. Next one is what? Case 4. Case 4. Okay, what is case 4? I am checking the continuity of the function at x equal to a. What is a value here? A value is in between 1 and 3. So right here 1 less than a less than 3. Okay, so what to do? I am checking continuity at x equal to a where a value is in this interval. When I say function is continuous at x equal to a, limit x approaches to a, f of x equal to f of a. Then I can say that this function is continuous at x equal to a, right? So here what I'll do, I'll calculate limit x approaches to a, f of x. I'll calculate this. Okay, that equal to limit x approaches to a. I'm trying to calculate this, right? As x approaches to a, what is a value? A value is in between 1 and 3. When a value is in between 1 and 3, which function to choose? We need to choose the function 4. Okay, so in place of f of x, I'll write 4. Now I need to calculate this. This is direct method. What is direct method? In the given function, wherever x is there, there we'll write a. Actually, in the given function, x is not there. Only 4 is there. So what you will get here? 4. Now I need to calculate f of a. Calculate f of a. To calculate f of a, you need to know what function to choose. Here a value is in between 1 and 3. Now when a value is in between 1 and 3, the function is 4. So f of x is 4. When f of x is 4, what is f of a? What is f of a? Suppose f of x is 4, what is f of 100? F of 100 is 4, f of 1000, f of 1000 is 4. For some constant a, f of a is what? F of a is 4. So in this case, f of a is 4. Okay, so what I got when I calculated this, I got 4. When I calculated this, I got 4. So what I can say, limit x tends to a, f of x equal to f of a. Therefore, this function is continuous at x equal to a. So I'll write that one only. Look here, this one. What I got here actually. Therefore, limit x approaches to a, f of x equal to f of a. Therefore, I'll say that f of x is continuous at x equal to a. In this case, a value lies in between 1 and 3. So I am trying to check the continuity in this zone. I checked the continuity in this zone. What I got? I got that it is continuous. So in case 3, there is no point. Sorry, in case 4, there is no point of discontinuity. So case 4, what happened? It is continuous. Okay. Now I need to check the continuity of the function at 3. Now I'll check the continuity of the function at 3. Okay. So case 5. Before starting case 5, I'll take this function and we need this number line. Okay. Case 5. Case 5. What is case 5? At x equal to a, and what is a value? Where I am checking continuity? At 3. A value is 3. So what I am checking here? I am checking continuity at x equal to 3. When we say function is continuous at x equal to 3, when we say function is continuous at x equal to 3, we know this. Limit x approaches to 3, f of x equal to f of 3. Limit x approaches to 3, f of x equal to f of 3. Then we say that the function is continuous at x equal to 3. So what I'll do? I'll calculate this one. To calculate this one, you observe here x approaches to 3 is there. Na? X approaches to 3 means x values are slightly less than 3 or x values are slightly greater than 3 but not 3. This is what we learned from the beginning of this chapter. X approaches to 3 means all x values are slightly less than 3 or all x values are slightly greater than 3. When x value is less than 3, at that time function is 4. When x values are greater than 3, at that time function is 5. So to calculate limit extends to 3 f of x, you need to calculate left hand limit, right hand limit, because as x approaches to 3 from left, we need to choose the function 4. When x approaches to 3 from right, we need to choose the function 5. So what I am trying to say, to calculate this value, I need to calculate left hand limit and right hand limit. Okay, I'll calculate left hand limit. How to calculate left hand limit? Limit x approaches to 3 from left, f of x. Okay, that equal to limit x approaches to 3 from left. X approaches to 3 from left means all x values are less than 3. When x values are less than 3, which function to choose? The function is 4. Okay, equal to, how to calculate this? Direct method. What is direct method? In the given function, wherever x is there we will write 3. Right here in this given function, there is no x. So direct answer we will get. The direct answer is 3. Now I'll calculate right hand limit. Okay, limit x approaches to 3 from right, f of x. Okay, that equal to limit x approaches to 3 from right. X approaches to 3 from right means all x values are greater than 3. You look here, 3 is less than x means x is greater than 3 only. So when x value is greater than 3, which function to choose? We need to choose 5. Okay, so here the function is 5. Now what to do? I need to calculate this limit. Direct method. As there is no x here, we will get answer as 5. Okay, now I calculated left hand limit, right hand limit. Left hand limit is 3, right hand limit is 5. You observe, left hand limit is 3, right hand limit is 5. They are not equal. Left hand limit is not equal to right hand limit. So what I can say about this limit? This limit value exists or this limit value does not exist? This limit value does not exist because left hand limit is not equal to right hand limit. Okay. So what I can say here? I can say that this value does not exist. When this value does not exist, we cannot check the condition at x equal to 3. Therefore, f of x is therefore f of x is not continuous. F of x is not continuous at x equal to 3. Okay, so what happened here? Look, what happened here? At x equal to 3, what happened? I got that this is not continuous. At x equal to 3, this is not continuous. In the process of checking continuity, I came to know that at x equal to 1, this is not continuous. At x equal to 3 also, it is not continuous. Total 5 cases are completed. Another 2 cases are remaining. Okay. This is the function and this is the number line that we needed to check which case we are doing. Okay, so 5 cases are over. Case number 6. Case 6. What is case 6? I am checking continuity at x equal to a. What about a value? This is case 6. Now I am checking the continuity of the function in between 3 and 10. So here I will write where a is 3 less than a less than 10. Here a value is in between 3 and 10. When we say I need to check the continuity of the function at x equal to a. When we say function is continuous at x equal to a, if limit x approaches to a, f of x equal to f of a, then I can say that function is continuous at x equal to a. So to calculate this, what I'll do? First I'll calculate this one. Next I'll calculate this one. If both are equal, then I say that this function is continuous at x equal to a. So I'll calculate limit extends to a f of x first. Limit extends to a f of x. Okay, that equal to limit x approaches to a f of x. What is the function? X approaches to a value is in between 3 and 10. When a value is in between 3 and 10, we need to choose the function 5. So what is f of x here? F of x is 5. So f of x is 5. So we need to calculate this limit. How to calculate? Direct method. in this function wherever x is there, there will write a. Actually, in the given function x is not there, so you will get the answer directly as 5. Okay, now I need to calculate f of a. I'll calculate f of a. To calculate f of a, you need to know which function to choose. F of x. Here, this is the case now. In this case, the function is 5. F of x is 5. What is f of a? As f of x is constant function, f of x is 5. What is f of 100? F of 100 is 5 because this function is nowhere linked with x, nowhere dependent on x. F of 1000 is what? F of 1000 is 5. What is f of a? F of a is also 5, right? F of a is 5. So f of a is 5. What happened? I calculated this, I got 5. I calculated f of a, I got 5. From that I can say that these two are equal. So what I got? I got that limit extends to a, f of x equal to f of a. Therefore, limit extends to a, f of x equal to f of a. What I can say? I can say that f of x is continuous at x equal to a. What do you know about a value? 3 less than a less than 10. 3 less than a less than 10. So the function is continuous in this zone. So here what happened? I checked the continuity in this zone. What I got? I got that it is continuous in this part. Okay. So tick mark for this. So I total 6 cases are over. In all 6 cases, what I identified? I identified that this function is discontinuous at x equal to 1. This function is discontinuous at x equal to 3. Last one. What is this last one? I need to check left continuity of the function at 10. I need to check left continuity of the function at x equal to 10. Okay, case 7. I'll take this function. Okay, we need these things, right? Okay, so case 7. What is case 7? What is case 7? I am checking the continuity at x equal to a. A value is what? A value left continuity at 10, 10 minus. This indicates that all x values are less than 10, very nearer to 10. Okay, so when I can say the function is left continuous at 10, limit x approaches to 10 from left, limit x approaches to 10 from left, f of x equal to f of 10, then I can say that this function is left continuous at x equal to at 10, left continuous at 10. Okay, so what I'll do, I'll calculate this one. Next, I'll calculate this one. If both are equal, then I can say that this function is left continuous at x equal to 10. Okay, so first you calculate this one, right? Limit x approaches to 10 from left, f of x, that equal to limit x approaches to 10 from left. X approaches to 10 from left means all x values are less than 10. When x values are less than 10, which function to choose? We need to choose this function 5. Okay, f of x is 5. Now what I'll do in this function, how to calculate this direct method? In the given function, wherever x is there, there you write 10. But in the given function is independent from x, so we will get its answer directly. Its answer is 5. So when I calculated this one, I got it as 5. Now I need to calculate f of 10. Okay, to calculate f of 10, first you need to know which function to choose. Which function to choose in this case? This case is about x values are less than 10. X values are less than 10 means we need to choose the function as 5. F of x is 5. As f of x is 5, what is f of 10? F of x is 5 means it is a constant function. This function nowhere independent of x. F of 100 is what? F of 100 is 5. F of 1000 is what? F of 1000 is also 5. What is f of 10? F of 10 is 5. So here for this case, in this case, f of 10 is 5. So what happened? I calculated this value, I got 5. I calculated this value, I got 5. So what I can say? I can say that limit extends to 10 from left, f of x equal to f of 10. From this what I can say? I can say that f of x is left continuous. F of x is left continuous at x equal to 10 from left. Okay, so what happened in this case 7? Tick mark or into mark? Yes, it's a tick mark. It is continuous. What they are asking in the question, find the, let me go through it. What they are asking, discuss the continuity of the function. So what happened? I first thing I identified its domain. First thing I identified its domain. Its domain is closed interval 0 to 10. So I am checking the continuity of the function in its domain. We got total 7 cases. I came to know that it is continuous everywhere, but it is except at 1 and 3. That means this function is discontinuous at x equal to 1 and it is discontinuous at x equal to 3. So what I'll write, therefore, 1 minute, therefore from all the cases above, what is the conclusion we can give? I can say that f of x is discontinuous at x equal to 1 3 na, at x equal to 1, at x equal to 3. F of x is discontinuous at x equal to 1 comma x equal to 3. So this function is, given function is discontinuous at x equal to 1, at x equal to 3, and in remaining parts of in its domain it is continuous. This function is continuous in its domain except the points 1 and 3. I hope you understand this. See, this problem is easy only, but it is little lengthy. Okay. What I request, so many students are watching these videos, but if you like these videos, I will get more energy to create many videos like this. I hope you understand this problem. If you like this video, please drop a like for this video and share this video with your friends, and don't forget to subscribe to my channel. Thanks for watching. Take care. Bye bye.